Okay, welcome back. So we're just going to pick up where we left off here. So I've got two different situations here. So first one, you got two different equations, y equals negative 2x plus 3 and y equals 2x minus 7. In the second situation, you've got y equals negative 0.75x or y equals 0.7x. In each situation, I want you to tell me which line would be steeper. Okay, so quickly take a look at it and circle the one that you think is steeper and push play, ready to go through it together. Okay, so if you take a look at the first one here, it is a little bit deceiving, a little bit of a trick here. The first one, if you're looking at the slopes here, you're looking at the values here. Here we have a slope of 2, here we have a slope of negative 2. So this one slopes up to the right, this one slopes down to the right. So the only difference between these is that one is positive slope, one is a negative slope. Their actual steepness is actually identical to each other. Okay, so if you were to put these both in a graph, and I'll let you guys test it yourself, throw it into Desmos, graph them both and see what they look like, you'll see that they actually are the exact same steepness, just going in different directions. So here, actually none of them are steeper. Okay, in the case of the second one, we have y equals negative 0.75x and y equals 0.7x. As for which one's steeper, well, it's going to be the first one here. Now, again, even though this one is negative and this one's positive, the actual steepness is actually going to be larger in this one because the value of the slope, if you ignore that negative, is larger than this one here. So again, this one slopes down, this one slopes up, but because this one has a larger value, if you ignore the negative, this one's actually going to be steeper. Okay, so next we're going to review how to graph. So here's the equation, negative 7x minus 3y equals 21. And I'm going to graph it two different ways. One using intercepts, so that means finding the x and y intercepts. And the other one is to graph it using the slope and y-intercept, which means putting in a slope y-intercept form. So we're going to do it both ways. If you want to try this on your own first to see if you're on the right track, by all means pause the video and do that. But I'm going to go through it right now for those of you who completely don't remember how to graph. So I'm going to start by doing it the first way here using intercepts. Now, just a bit of a word of a warning. Using intercepts is a great method. It doesn't necessarily work great all the time, because sometimes the x and y intercepts aren't nice integer values. In fact, that happens a lot of the time. So it will work sometimes. It's a nice little method to give you an approximation, but it isn't always exact. But I'll show you guys how it works here anyway. So in this case, you want to find the x and y intercepts. So remember here from a couple slides ago, if you want to find the x-intercept, well, anywhere the x-intercept is going to be, the y value is going to be 0. Okay, so it means we take this equation and replace the y with 0. So I'm going to get negative 7x minus 3, and the y is now replaced with 0. Okay, so once we've replaced the y with 0, we can actually rearrange the equation and solve for x. So negative 3 times 0 is just 0, so that goes away. I'm just with negative 7x equals 21. And if I divide both sides of the equation by negative 7, I'm just left with x equals 21 divided by negative 7, which is negative 3. Okay, so that's telling me my x-intercept on the graph is going to be over here at negative 3. Okay, so that would be how I find the x-intercept. So if I want to actually make the graph, though, I need a second point, so I need to find the y-intercept as well. So to find the y-intercept, I do the opposite of what I just did. So at the y-intercept, the x value is going to be 0. So I've already seen x in the equation, I replace it with 0. So I'll have negative 7 times 0. You may not find it necessary to write out this step. I'm just writing out to show the step, so you see where everything comes from. But to test your quiz, if you don't need to write this step, if you feel like you can do without it, you can skip it. But negative 7 times 0 is 0, so you're just left with negative 3y equals 21. So if you divide both sides by negative 3, you wind up with y equals negative 7. So that tells you your y-intercept down here is there. Okay, so you put that point on the graph. You've got your 2 points now with the x and y-intercepts. You have enough to make a line. So use a ruler, please and thank you, so it's a nice and clear line. But your line would look something like this on the graph. Hopefully yours looks a little bit better than mine, but you get the idea. You have a line passing through the 2 points you just found. Okay, this would be one way of graphing. Now, just one thing I want to mention here when you're graphing, make sure you have arrows on the end, okay, because these lines do continue on forever. So that would be one way of graphing. Now again, some of the limitations is if your x and y intercepts are decimals or ugly fractions, it's hard to make an accurate graph. That might be an issue no matter how you try and graph it, but it's just something that can pop up. So I'm going to try this again using the slope and y-intercept, which means I'm going to put it into slope-intercept form, which if you remember is y equals mx plus b. Okay, so you may run into this type of question already on the worksheet, but because we want y equals mx plus b form, what we need to do with this equation here is isolate the y. Once y is by itself, we will, by default, be in slope-intercept form. So what I'm going to do is I'm going to leave the negative 3y alone. I'm going to move the minus 7x over to the other side. Well, how am I going to do that? Well, I see how it's minus 7x over here. I'm going to add 7x to both sides of the equation. So that's going to give me, once I simplify that, minus 3y is all that's left on the left side of the equation. And I'm going to have 7x plus 21 on the right side. Now you might ask, well, why not just write 21 plus 7x? You absolutely could, but to keep it in mx plus b form, I'm writing the x term first. So I have negative 3y equals 7x plus 21. Now I'm almost done. The only problem is I need just y by itself. I have negative 3y. So what I'm going to do now is I'm going to divide the left side of the equation by negative 3. Remember, since I'm dividing the left side of the equation by negative 3, I have to do the same thing to the right side. So that means I'm dividing every term on the right side by negative 3 as well. Okay, so here those are going to cancel, so I'm just going to be left with y. Now, here I have 7 over negative 3. That does not simplify nicely, so let's leave that as a fraction. So I'm going to have negative 7 over 3x. 21 divided by negative 3 is minus 7, so it will be minus 7. So y equals negative 7 over 3x minus 7 is my equation in slope-intercept form. And that'll tell me everything I need to do to make a graph. So because I'm in slope-intercept form, right here, this minus 7 gives me my y-intercept. So I'm going to put that on the graph. You'll see it matches what I got when I did this the other way. But now I need to use my slope to create other points. So a slope of negative 7 over 3 means I have a rise of negative 7 and a run of 3. So from here I would go down 7 and over 3 to find another point. Now with my particular grid, I've run out of room on my grid. If you were using your own graph here, you might have space to continue on, but you'd go down 7 over 3, down 7 over 3, and in theory keep going, make as many points as you want. Since it doesn't fit on my grid, I'm going to go the opposite direction. So instead of going down 7 over 3, I know my line should be sloping down from left to right. So instead of making another point down here, I'm going to make another point up here. So I'm actually going to go up 7 and over 3 to the left. So up 7 over 3 on my grid gives me another point right here. I could go even further. I could go do another one, go up 7 and over 3 and put another one here. And I could keep going forever, but I'm out of space on my grid. So once I have enough points here, I'm happy. I'm going to create my line. So line going through all the points I've drawn. Make sure you put your arrows on the end. I'm missing one down here. So there's my line. So two different ways of graphing. One way is putting it in slope-intercept form. One way is finding x and y intercepts. Okay. All right. So let's move on. So here there's 3 tables of values, and I want you to tell me which ones of these represent lines. And if they are linear, I want you to tell me the slope. There's a few ways of going about this. You may remember something to do with first differences from grade 9. You may find it easier to just graph each one of them and see what kind of graph it gives you, and then kind of find your own conclusions from there. So I'm going to give you a chance to try this on your own first, on your own or with a partner. So pause the video and push play and ready to go through the answers together. Okay, so before I talk about first differences, I'm going to see what these look like on a graph. So here's A on a graph, and you can see from looking at that graph, this is clearly linear. Okay, if you take a look at B on a graph, you'll see that this is clearly not linear. The points are kind of all over the place here, no real set pattern. Okay, and if I connect this third one here, you'll see when it makes the graph that this is linear as well. So the question is, can you find out just by looking at the table? And the answer is yes. So if you look back, if you remember back to grade 9, you did something with first differences. So first differences are when if you look in your x values, they're going up by the consistent amount every single time. So in case of A, the x values are going up by 1 every single time. You can look at the first differences by subtracting the consecutive y values. So here I go 4 minus 7, which gives me negative 3. And these are, again, are called first differences. Okay, 1 minus 4 gives me negative 3, and so on and so forth. Negative 2 minus 1 gives me negative 3. Negative 5 minus negative 2 is also negative 3. You'll notice here that all the first differences are the same. Okay, and this one was linear when we put it on a graph. Okay, if you look at the second one, which when we graphed was nonlinear, well, this one's a bit misleading, because if you look at the y values, you'll see they're going up by 2 every single time. So if you might fall into a trap of thinking, hey, the first differences are the same, they're all going up by 2 every single time, so this one's linear. But if you look at the x values here, they're not going up by consistent amounts. You need that to be the case in order for first differences to work, to tell you whether it's linear or not. So you'll see here going up by 1, up by 2, up by 3, up by 1. There's no real consistent pattern here with the x's, so the first differences aren't really meaningful. So this one is nonlinear, and you can tell that when you take a look at the graph. And this one, when we graphed, we saw it was linear. And you can see if you look at our x values, we're going up by 2 every single time, so it's consistent. And if you look at our differences here, negative 4 minus negative 5 is 1. Negative 3 minus negative 4 is also 1. And if you keep going, you'll see y is going up by 1 every single time. So that's how you can find out if it's linear or nonlinear. Now, to find your slope, there's 2 ways of going about it. You can take a look at any 2 points that are in this chart here and find the slope. So let's just say we want to take a look at that. Let's say I want to take a look at these 2 points. I could find the slope using rise over run. So my y, I can go, change in y is 4 minus 1. Okay, change in x is negative 1 minus 0. 4 minus 1 is 3. Denominator is negative 1. So I get a slope of negative 3. Okay, and that's a perfectly good way of finding the slope. I'll do the exact same thing down here. For my slope, let's say I take, I don't know, let's say these 2 points. I'll go negative 3 minus negative 2, all over 0 minus 2. So that will give me negative 1 over negative 2, which is a half. Okay, so if you want a slightly faster way of getting the slope from tables of values, you'll notice here that my first differences were negative 3, and my x values are going up by 1 every single time. So if you go negative 3 over 1, that gives you negative 3. Same thing happens here. My y values are going up by 1. My x values are going up by 2 every single time. 1 over 2 gives me my slope. So it's just a potential shortcut there if you happen to see that. All right. So a couple more examples left. So with this one here, it says express in slope-intercept form. So that's putting it into y equals mx plus b form. We did an example of this back when we were trying to graph the one on the last slide. So I want you to try this. Get y by itself. Do it on your own first after you push pause, and push play and ready to see the answer. Okay, so if you want to check your answer, you should get something like this. Y equals 7 over 3x plus 4 over 3. To remind yourself of the steps, I'm trying to isolate y. So I started by moving the 7x over to the right side of the equation by subtracting it from both sides. So that cancels over here. I get negative 7x minus 4. And then I had to get rid of that negative 3 because I need just y, not negative 3y, so I divided every single term by negative 3. When simplifying, just be very, very careful. If it doesn't reduce nicely, leave it as a fraction. And you'll notice here I have a negative 7 over negative 3. The negatives cancel, so I get positive 7 over 3 for my slope. Here I have negative 4 over negative 3, so I get positive 4 over 3 for my y-intercept. This particular one would be an absolute nightmare to graph. But again, it's just a useful form that you could potentially use for something else. Okay, so one last set of examples here involves finding equations of lines based on different information. So here you're given the graph and you want to find the equation. Here you're told it's perpendicular to a different line passing through another point. And here you're told it's passing through a couple points. So what I'm going to have you guys do, just read through them, do what you can on your own first, and we're going to go through these together in part 3 of the lesson, and we'll see you over there in the next video.